Hey, buddy, how are you? Good, good. Things have been really busy. How about you? Well, I got some travel coming up, kind of excited about it, but I have to get through some work first. I understand. That's an entirely scripted conversation. That's why I'm trying to say that I want to do podcasting that is outside of the LLM model. I don't want to do just dangerous, stupid stuff, but I want to talk about things that I've never explored, where I don't have something, ready.
Do you think AI will ever break out of the LLM, or will it expand?
I don't think the LLMs will. I think that waiting for AGI as the problem is a bad idea. I think the problems are going to get here far before AGI. I think even that, the AGI expectation is something we're trained to do. Do you think AGI is coming? Do you think we'll survive AGI? Will AGI be good or bad? All of that's pre-programmed into you. Why are you waiting for AGI? Did you not AlphaFold3? Did you track that? Do you know about this?
Was that the chess game?
It's the chess game that became the protein folding game.
Oh,
and you want to talk about great games, protein folding. Now that's a game.
I have no knowledge of this at all.
Okay. What do you know about proteins?
Very little.
Okay, think about proteins as tiny machines.
Yeah.
That there's a copying machine, there's a scissors and a shearing machine, there's a light making machine, all sorts of things. And all of those machines are weirdly coded. Imagine that you had like a children's show and a bunch of girl superheroes, and they all had necklaces with 20 different kinds of beads around their neck. And so when they needed a machine, they'd take off the necklace and they'd throw it into a thing called a ribosome. The ribosome would take these 20 kinds of pearls and suddenly it would build you a car or a spaceship or a gun or who knows what. Well, that's the story of DNA, RNA, and protein. The only thing is, isn't it weird that a linear sequence suddenly crumples up into a three-dimensional object that does something? So for example, I don't know if you've ever seen these Turkish rabbits that glow in the dark?
No.
Okay, so they took green fluorescent protein out of jellyfish.
Yeah.
And they spliced them into the nucleic acids of rabbits. And the Turks bred all of these glow-in-the-dark bunnies. And what that is a structure. So there's something called secondary structure in protein, where sometimes you get these spirals called alpha helices, and then sometimes you get a two-dimensional sheet that's made from taking a switchback in strings of amino acids. And then if you wrap that around, you don't have a beta sheet, you have a beta barrel. And these beta barrels are the glow-in-the-dark aspect of green fluorescent protein, okay? And what we didn't know was how a series of ACTs and Gs could code for sequences of amino acids could form three-dimensional structures. So if you just read DNA, you didn't know, well, that's going to be a sports car.
Yeah.
Well, AlphaFold figured it out for the most part, like to an enormous extent. Humans were stuck there.
And what does that mean?
It means that you could, you could target your enemies that have particular regions on their cell surfaces, and you could come up with proteins that only attach to them and attack. It could mean anything. It could mean nanorobots. I don't know what it means, but my point is that that's already here, and you're not focused on it. And you're thinking AGI